Hello, my name is Garbezza. This is Javier Rojas, Juan, Manuel, Valencia. We are Team 12, presenting our third project for modeling and control of robots. We are presenting a thermal spray robot. Thermal spray coating is a process where a melted material is sprayed onto another object, provides a thick, uniform coating over a large surface area. It's usable with metals, plastics, ceramics, and composites. Now, the applications for this type of development are very wide. It's used in aerospace, automotive, electronic, energy, textiles, marine, and printing industries. Now, the thermal spray is used to harden materials. It gets desired surface type and texture and increased surface strength, makes materials resistive against oxidation, abrasion, and corrosive gases. It also alters electrical properties, making materials more conducive or less conducive. It is relatively low cost compared to other coating methods. Now, robots are used to increase safety. The maximum temperatures of 15,000 degrees Kelvin using plasma sprays for refractory coatings. It also involves higher precision, and the high precision demands are used for the machines not to get damaged. Now, machines today, thermal spray machines today are generally electrically controlled rather than hydraulically or pneumatically. The automation can be acquired by using multiple robots to position and spray objects. This removes the human error and speeds up the production, which in turn reduces cost and the amount of material waste. Now, general robot designs consist of 6 axes for 3D robots. There's 3 revolute joints at the base and end of the first and second links. There's 3 plane rotation joints for detailed multi-directional end effector control.
Now, the robot design. The design that we chose was a 3 revolute joints robot. We picked the values of A1, A2, A3 to be fixed at 4 feet. And also we fixed the end effector angle, or phi3, to be 90 degrees. Now, the solution that we want to achieve with this was the values of the theta 1, the phi1 and phi2, the angles of the 2 links. And then our robot was desired to do two motions on the end effector, a rectangular motion and an arc motion. Now, to achieve these 2 motions, we use the inverse solutions. With this, we have to solve 2 nonlinear equations simultaneously. With solving this, we're gonna get 2 answers for phi1 using these equations. We're gonna get one for the plus sign and one for the minus sign. When we get this, with these values, we're gonna plug in these equations, finding 2 solutions for the joint angle of the link 2.
These are the actual plots of our joint angles. So you can see, as mentioned, there are 2 solutions. This is called closure 1, closure 2. So one of the first things you can notice is that closure 1 and closure 2 are symmetric. Here it is phi1, this is phi1, as you can see, it behaves the same as phi2, phi2. Another thing to take note of, notice the sharp changes in angles. This is due to the fact that when we move in a square motion, we're changing the curve very sharply at certain points. As you'll see later, when we do a more smoother motion, the angles are actually going to be continuous. Now this is the actual path of our points. This is the end effector. As you can see, it moves in the square path we wanted. This is the end of joint 2. Since the end effector angle is fixed at 90 degrees, all of them should correspond a 90 degree square path between the end effector and joint 2, and this is joint 1 moving, sort of rocking back and forth in this angle. Now, as we noticed, again, as they're symmetric to each other, here you can see, joint 1 here behaves opposite of this one, these 2 behave the same, they're symmetrical. This is something I want to notice. First, notice how this one is smooth, since we're going in a continuous arc, as opposed to having very jagged edges on the other one. Another thing to take note of here, as you can see, the angles are kind of pinching, or on here and up there in both closures. These, when we analyzed the system, we discovered that it had a singularity point whenever the two angles were equal to each other. We wanted to avoid this, so we changed our robot parameters to only operate within this area. You can see both of them are limited, so you don't reach a singularity point. These are the paths for the arc. So you can see, here's the end effector, both closures moving in an arc. Here is joint 2, moving in an arc below it, 90 degrees for all points. This is the path to joint 1, oscillating back and forth as these things move like that.
Now the 3D modeling of our robot was done on SolidWorks. As we can see from here, we have 3 links, one base, a fixed base, and the end effector that we put a gun spray to simulate the movement of the end effector. Now we're gonna see the 2 animations that the end effector is gonna have, one with a square motion and the other one with arc motion. So here is the front view of the arc motion, of the square motion. As we can see, the end effector goes exactly as the path described by Javier on the MATLAB graphs. Now this is the same motions on isometric view. As we can see, it's in a 2D plane motions, so it just goes in the X and Y direction. The third motion shows the arc path done by the end effector. As we can see here, we have to cut the video because the end effector will, the robot will go to the singularity position, so it will, the robot will just. Now the last one is the same motion, the arc motion, but in isometric view. The same is a 2D motion. Now, in conclusion, for the spray coating robots, with these robots we can improve the performance of the coating on the materials. We lower the cost of the production because it's just done by a robot, not by humans anymore. Also, we improve the safety because we don't have humans involved on the coating, and improve the production time because it's done by a robot. So the typically robots that are used for coding has 6 axes and has 3D placement. Now for the future in these robots, we can see a better coding, also more precise robots, and finally we're gonna achieve more automation and near removal of humans on the robot. Thank you.